of a 25% ethanol solution in mice that are 3 months old versus mice that are 9 months old. I'm doing so by measuring factors such as weight difference, food intake, water intake, and behavioral changes using various behavioral assays. More on that later. My big question is, how does aging affect the effects of alcohol in mice of different ranges, specifically that of 3 months old and 9 months old? A little background on what we know for alcohol and human aging. Alcohol use among older adults can have unique risks and consequences, even in lower amounts than younger persons. Physiological changes that occur with aging can increase sensitivity and decrease tolerance to alcohol, making older adults more vulnerable to the psychoactive effects of alcohol. And higher quantities of alcohol use by older adults has been associated with functional impairments and an increased mortality risk. So just based off these three statements and a bunch of other research papers that we've read, we hypothesize that the older mice that are 9 months old exposed to ethanol will show a greater physiological and behavioral impairment compared to younger mice, mice that are 3 months old, exposed to the same experimental conditions, as evidenced by a decreased body weight, altered food or weight consumption, or liquid consumption, an altered performance in behavioral assays such as the elevated plus maze, the 3-chambered sociability test, the forced swim, and the accelerated rotarod. I just threw a bunch of stuff at y'all, but I'll get to it later. All right. So now I'm going to describe my methods really quickly. So I'm going to describe my treatment paradigm first. So basically, control mice are isolated and given 100% water to drink, as well as an adequate amount of mouse chow that will last them for 5 days. Mouse chow is just mouse food. The experimental mice, however, they're also going to be isolated, just like the control mice, but they're going to be given a 25% ethanol solution in water, as well as an adequate amount of mouse chow that will last them for 5 days, just like the control mice. Every 24 hours, I'm going to weigh the mice to record any changes, as well as measure how much food and liquid was consumed by the mouse every single day, so we can keep a track of that. Because we have 3 variables in this study. We have the sex of the mouse, we have the control or experimental condition, and the age groups. There's going to be 8 main groups being compared in this study. There's the male control mice at 3 months, the male experimental mice at 3 months, the female control mice at 3 months, and the female experimental mice at 3 months. To save everyone some time, I'm just going to say it's the same categories except at 9 months for the other 4. Now I'm going to talk about the behavioral assays a little bit. So first, we have the elevated plus maze. This is commonly used to assess anxiety-like and risk-taking behavior, which involves a plus-shaped maze with 2 open and 2 enclosed arms elevated above the ground. Next, we have the 3-chambered sociability test. This measures social preference in rodents by allowing test mice to choose between spending time with another stranger mouse or a non-social object. In our case, it was a pencil holder in a 3-chambered arena. Forced swim. So forced swim is commonly used is a commonly used behavioral assay to measure depressive-like behavior in rodents, which involves placing a test mouse in a cylinder of water and measuring the amount of time that the mouse spends immobile. Last, we have the accelerated rotarod. This measures the motor coordination and balance, and it involves placing a test mouse on a spinning, rotating rod, hence rotarod, that gradually accelerates in speed. This is kind of like a mouse treadmill. So now I'm going to talk about my results that I've gotten so far. This is for my 3-month mice. This slide specifically focuses on weight differences, food intake, and water intake. Over here on the left, we see the weight change. So for both of the groups, we see a significant difference in weight change in both the male and the females at this age group. So for the control mice, whenever we put them on the experimental paradigm, when they were just drinking water, the male mice actually did not lose any weight at all. They kind of stayed close to 0. The females, they lose a little bit of weight, probably 0.7 of a gram. But the ethanol mice actually lost a lot more weight. So it was losing 5 grams for the ethanol mice for males and around 4 for females. For food weight change, we see no significant differences in food intake for either male or females at the 3-month groups, so they were pretty much eating the same. And the liquid change, we see no significant differences, again, in liquid consumption for either the male or the 3-month female group. So yeah, they were pretty much drinking the same. We see that the ethanol mice were drinking just a little bit less, but nothing significant. All right, so now I'm going to talk about my 3-month mice behavioral assays. So first, we're going to be covering the elevated plus maze. That's here on the left. We see significant differences in time spent on the open arms in both the male and the female groups. So for the control mice, we see that they spend a lot less time on the open arms. This basically means that they like being in the covered arms more, which is kind of more secure for them. The ethanol mice spend more time on the open arms, which kind of signifies that they're more willing to engage in risk-taking behaviors when they're on ethanol. For the sociability chamber, we didn't see any significant differences in sociability for either the male or the female 3-month group. So yeah, it was pretty much the same amount of time that the mouse spent with the stranger mouse I had never seen before between the control and the ethanol groups for both of the sexes. Third, we have the forced swim test. We see a significantly increased idle time for the experimental group in the male 3-month group. I accidentally miswrote. So we see here that the control mice actually spend a lot less time immobile, which is basically when they're kind of just floating in the water and they don't try to swim anymore, compared to the ethanol mice. We see that the ethanol mice actually tend to sort of give up on swimming a lot more often than the control mice. We also sort of see this on the females, but the difference wasn't as significant, although we do see sort of a trend going on. So maybe once we increase our sample size for that group, we might be able to see some significance later on down the road. Last, we have the accelerated rotor rod test. So here we see a significant difference for time spent on the rod for males that are 3 months old. So we see that the control males, they're actually doing significantly better than the ethanol males. They're more likely to stay on that treadmill for longer amounts of time than the mice on ethanol. We sort of see the same trend for the control females, although we did have a larger standard deviation for this. So it wasn't as significant, unfortunately. Maybe again, with the increased sample size, we might be able to see some significance, however. All right, so now I'm going to talk about my preliminary results for the 9-month mice. I'm not done collecting data on my 9-month mice yet, so all of this is subject to change. So first, like the 3-month mice, we're going to look at the weight differences for food intake, weight differences in the water intake. So first, let's look at the weight change. We see a significant difference in weight change in the male 9-month age group. So again, we see that the control mice tend to lose less weight, or it tends to stay the same almost compared to the ethanol mice, which lose a little more weight. So we see a significance for the males, not so much for the females. Same thing for the food intake. We actually see a significant difference in food intake for the male 9-month group. So although the food intake was the same for 3-month mice, at 9 months we actually see that the ethanol mice, the mice that are on ethanol, they eat a lot less than the control mice every day. For females, we don't really see a difference. And yeah, that's pretty much it. So now we're going to talk about the liquid change. Same thing. We do see a significant difference in liquid consumption for the males in the 3-month group. This one's kind of interesting because the ethanol mice actually drink more than the control mice, which was something that we weren't expecting. But yeah, like I said previously, once we increase the sample size for all of the 9-month male and females, we should be able to see some leveling off or something like that. That's what I predict, at least. All right, so last slide full of graphs, I promise. This is going to be our preliminary results for 9-month mice. First, we're going to start off with the elevated plus maze for 9 months. Here again, we see a significant difference in the time spent in the open arms in both the male and the female groups. So the mice on ethanol are a lot more likely to engage in risk-taking behaviors than the ethanol or the control mice, is what that basically tells us. For the sociability chamber, we see a significant increase in sociability for the males in the 9-month group. So the ethanol mice are actually a lot more social than the control mice at this age group. And we sort of see that for the females too. Again, nothing is set in stone right now because our sample size is still pretty low. So again, it's subject to change, but we do see a significant difference right here. For the forced swim at 3 months, we don't see significant differences for either the males or the females. We can kind of see that the ethanol males resemble the same thing that it did at 9 months. This should say 9 months, by the way. Sorry about that. So yeah, and again, we don't see a significance because our N is still kind of low. And for 9 months, we also see the same thing. The control mice do better than the ethanol mice. It's staying on that treadmill. Same thing with the females, although the numbers are a little wonky here. Again, hopefully with that sample size being raised, should be a little more pretty looking, I guess. All right, so last slide. I'm going to talk.
We're a little over time, so I'm wondering if you're able to just gently bring us to the conclusion.
Yeah, of course. So right now, what we can see for differences is that there is a difference between the mice put on our ethanol treatment versus our control treatment, which in non-scientific terms basically means that our drug mice behave differently than our control mice. I was hoping this would be the case. And there may be differences in liquid consumption for food intake between the 3 months and the 9-month age groups, differences in mouth sociability between the two age groups, and there may be differences on how much the mouse spends on the accelerated rotor rod between the 3-month and the 9-month age groups. So hopefully this can be used to develop more targeted and effective interventions for individuals of different ages who consume alcohol. And also it'll just work to improve animal models of alcohol use and abuse, which could lead to the development of better treatments and preventative strategies for alcohol-related problems in humans. Awesome. Thank you so much. Hope I didn't go too over. And that concludes my presentation. This is my work cited. Perfect. Thank you.